Kb and Kw of conjugate acid base pair. So if we take examples, suppose base with water is going to give NH4 plus OH minus. So here from this to this H plus H accepting, so this is base and this is to be acid. Similarly this is from here to here, so this is H plus donating, so this is acid and this is its conjugate base and this is its conjugate acid. So similarly, so for these reactions, if I say what is the Kb, if I ask the Kb, then concentration of product divided by concentration of reactants. So concentration of product is NH4 plus OH minus NH3. Water is not taken because it is very excess, so it takes as a unit. So this is the Kb. Similarly, if I take for, let's say yes, for this we are talking about a conjugate acid base pair. We are talking about conjugate acid base pair. So I take, so Kb for this base, Kb is this. So if I say the now take the Ka for this conjugate acids. So for this conjugate acid, if I say the reactions will be like NH4 plus H2O. This is going to give NH3 plus, this will be H3 plus. So from here to here, what it accept it donating H plus. So this is acid, and from here to here, this is accepting H plus, means this is base. So for this is the conjugate acid of this conjugate of this base. So I am taking for this conjugate acid the Ka of conjugate acid of NH3. What will be its Ka? So concentration of product by concentration of reactants. So if you observe this, then Ka and Kb, so I will take next page. So we get that Kb is how much? NH4 plus OH minus and NH3. So Kb is NH4 plus OH minus NH3, and for the conjugate acids, for the conjugate acid KH, NH3 H3O plus conjugate acids, that is NH3 NH4 plus. So this is the base for equilibrium constant for base, and this is the conjugate acid. So for this base, the conjugate acid equilibrium constant is this. So if I search, this is the reaction switch. This is the reaction. So from here to here, this is the base. This is acid. And similarly for this conjugate acid, if I write, then NH4 plus water, then it will give NH3 plus H3O plus. So for this base, this is its conjugate acids. So I take that Kb for this conjugate base is this, and for this base, its conjugate acid is this NH4. So I take the Ka for this conjugate acid of this conjugate base. So conjugate acid, we get this. So if I the multiplied by Ka conjugate acids of this base into the Kb of that base, what I get? So just multiply it, then NH4 plus minus then this NH4 plus this NH4 plus cancel, this NH3 cancel. So what's it remain? Ka into Kb equal to OH minus concentrations. Another is, sorry, this is NH3, this is H3O plus. So what's remain? H3O plus concentration. So what he here observe is that when you multiplied Ka into Kb, then we are getting that OH minus concentrations and H3O plus concentration, and note that this Ka and Kb, these are conjugate. We are talking about of the conjugate pair. So for conjugate pair, Ka, the equilibrium constant of acid and equilibrium constant of base, given that this and this are conjugate. If two acid base are conjugate, then this is equal to OH minus concentration H2O concentrations, and we know Kw equal to OH minus concentrations H3O plus concentrations. Then we can write Ka into Kb equal to Kw. So Ka equal to Ka into Kb equal to Kw. And the Kw, dissociation constant of water, it is constant at given temperature, like at room temperature 25 degrees centigrade, it is 10 raised to minus 14. We have already studied. So this value will change only if we change the temperature. So but Ka and Kb, if you change the this Ka and Kb will change with depend upon whether it is more acidic or more basic, but the Kw will be remain constant at a given temperature. So I can write Ka equal to Kw by Kb. So since this is constant, so we can write, we can write Ka. So this constant I remove, then I put the proportional constant, then this will be Kb. So given that acid and base are conjugate pair, that is, if Ka increases, then Kb will decreases. So if acid So if acid increases, then its conjugate base will decreases, because Ka is indirectly proportional to Kb. So inversely proportional, they have the relationships inversely. So if you increase the acid, then the acid's conjugate base will decreases, and if you decrease the acid, then its conjugate base will increases, because they have the inversely proportional relationship. So if I say HCl, so this is weak acid. So for this conjugate base, this is for this conjugate acid, for this acid the conjugate base is Cn minus. So this will be the strong base, because if Ka value is less than Kb of this acid, so the conjugate of this acid will be more. So if HCl is weak acid, then its conjugate base will be strong base. Similarly, if you say H2SO4, this is strong acid, so its conjugate base will be SO4 2 minus, and this will be weak base, because if it is a strong acid, then its conjugate base will be weak acid, because they have a relationship Ka is inversely proportional to Kb. So if Ka increases, then Kb will decreases. So the conjugate pair have the relationships of this. So if I search, and we can take examples like CH3COH, this is weak acid, then its conjugate base will be CH3CO minus, this will be strong base. So for conjugate acid base pair, strong acids will have weak, will have, I will write full sentence. So strong acid will have weak conjugate base, and strong base will have weak its conjugate acid. Similarly, weak acid then will have strong conjugate base. So for conjugate base, they have the inversely relationships. So if we have the strong acids, then its conjugate base will be weak base. So next topic is pH. This is the negative logarithm of base 10 of hydronium ions. Okay, so you can write pH equal to minus negative logarithm of base 10 H plus concentrations, or you can write pH equal to minus negative logarithm of 10 H3 plus concentrations. So if he says that, suppose for HA, H plus ions as 10 raised to minus 2 molar, then pH will be, then pH is negative logarithm of H plus concentration. So here for 10 minus 2 molar, then pH equal to minus negative logarithm of H plus concentration. So minus log 10 raised to minus 2 molar. So that will be what 2? So pH equal to 2. So this negative cancel, and log 10 raised to minus 2. So that will comes to part 2. This will be what? Minus 2 log base 10. So this will be 10 and this is equal to 1. So pH is equal to 2. So similarly if given that acids has H plus concentrations equal to 10 raised to minus 5, then pH equal to, then pH will be minus logarithm of H plus concentration. So minus log H plus is 10 raised to minus 5. So this will be 5 into log 10. So this will be 1. So that will be pH equal to 5. And example, suppose HCl, let's say HA has H3O plus concentrations equal to 10 raised to minus 7. Then pH will be, suppose for this the pH equal to minus negative with H3O plus concentrations. But here in this solution pH of the solutions it asks, then in, so this is happening in water solutions, then water itself is H plus and OH minus, and it is neutral, so water is neutral, so H plus concentrations is equal to 10 raised to minus 7. And so we are getting, this is from water, and we are also getting the H3O plus from acid, that is 10 raised to minus 7. So for this case the pH will be combine the H plus concentrations from acid and combine with H plus concentration from water. So pH equal to minus negative logarithm, that is this value plus this value. So that will be 10 raised to minus 7 plus 10 raised to minus 7. So pH equal to minus log 10 minus 7 plus 10 raised to minus 7. So this will be 2 into 10 raised to minus 7. So that will be 7 minus log 2. So that is 7. Log 2 means 0.3. So log 2 value is 0.3. Log 3 is 0.477. So you have to remember this value. So this will be how much? 6.7. So pH will be 6.7. So for this case I take the concentration of H3 plus for when HAH concentration is 10 raised to minus 7, and when the HA has the concentrations 10 raised to minus 5, I not include the H plus concentrations from water. Why? Because if you see that 10 raised to minus 7 and 10 raised to minus 7, so this 10 raised to minus 7 is very large compared to 10 raised to minus 7. So this will not affect this value. So what we have to remember, if HA has H plus concentrations, that is 10 raised to minus 1 to 10 raised to minus 5, then not include H plus concentrations from water. Why? Because I have 10 raised to minus 5 and 10 raised to minus 7, then 10 raised to minus 5 is very large than 10 raised to minus 7. So this value will not affect the concentration of H plus from acid. But if this value is like 10 raised to minus 7 or 10 raised to minus 8, so that 10 raised to minus 7 or 10 raised to minus 6, then this value is nearly equal to 10 raised to minus 7 of water. So for this case, if the concentrations, if HA has concentration of H plus equal to 10 raised to minus 6 or 10 raised to minus 7, then this value is closely with H plus concentration of water. So for this case, we will include H plus concentrations from water also. So if HA has the concentration that is equal to 10 raised to minus 6 or 10 raised to minus 7, on that case include the concentrations from water. And if the HA has concentration minus 5, minus 4, minus 3, minus 2, minus 1, then on that case that concentration of acid is very huge compared to concentration of water, H plus concentration from water. So on that case, concentration of water value will not affect our concentration of acid. On that case, we can neglect the concentration of H plus from water. So similarly for base case, so now we'll study the pH of base. So if we give that MOH minus MOH base has concentration of OH minus, that is equal to 10 raised to minus 10, then what is the pH? pH equal to this. So for that, what we know? So for this, P. So for acidic we are calculating pH, and for basic we will do pOH. That is also minus logarithm of OH minus concentrations. Okay, so given that OH concentration is 10 raised to OH concentration is 10 raised to minus 10, then pOH will be minus logarithm of 10 raised to minus 10, that is will become 10. So pOH equal 10. And one more thing, that pOH plus pH equal to 14. This is always at 25 degree centigrade. So if you know that, and if temperature is not mentioned, then assume that it is at 25 degree centigrade, or we can write 298 Kelvin. So we get the POH. So POH equal to 14 at 10, then pH equal to 14 minus POH. So pH equal to 14 minus 4, that is equal to, sorry, 14 minus 10, then pH equal to 4. So okay, so it cannot be 10 raised to minus 1, it has to be 10 raised to minus 4, because for basic the pH constant pH will be more than 8. So this value, so if you, okay, first we will study about okay, let's first study that. Let's discuss some theory, after that we will solve the problems. So what we know that, Kw equal to OH minus concentrations, H3O plus concentration. This we discussed in previous class, and it will be at, this is equal to 10 raised to minus 14 at 25 degrees centigrade. Okay, so if so for neutral solution, what is say that Kw equal to OH minus concentrations. So for neutral, what I say, for neutral, OH minus concentrations equal to H3O plus concentrations. So if it is neutral, if it is acidic, then H3O plus concentration is more. If it is basic, then OH minus concentration is more. And if it is a neutral, then OH minus concentration and H3O plus concentrations will be same. So Kw is OH minus concentration. So if this is same, so let's say I take it is X. So this is X, this is X. So Kw equal to, I can take it X square. Okay, and this is equal to 10 raised to minus 14 at 25 degrees centigrade. At 25 degrees centigrade, if you, so I already discussed that Kw is endothermic process. So for endothermic process, if you increase the temperature, then Kw is also increases. So at 25 degrees centigrade we get this value. If you increase the temperature, then this may convert into 10 raised to minus 12. So it value will increase, because Kw is an endothermic process. So at 25 degrees centigrade, Kw equal to X square equal to 10 raised to 14. So Kw equal to X square equal to 10 raised to minus 14 at 25 degrees centigrade. Then what I say, that X square equal to this, then X equal to 10 raised to minus 14, 1 by 2. Then X equal to 10 raised to minus 7. This is at neutral. At neutral, OH minus concentration and H3O plus concentration same. That's why we take as XX. So these are two are equal, then we can take as X square. That is equal to 10 raised to minus 14. So for neutral, this is equal. That's why we take the value X and X. If not equal, then this may be X, it may be Y, because these are not equal. So for neutral, these are equal. That's why we take XX. So 2, so X square. That's why X equal to 10 raised to minus 7. So this X, suppose H plus concentration, H plus or OH minus concentrations equal to 10 raised to minus 7. because we have taken x equal to 10 raised to x equal to, we have taken OH minus concentration or H plus concentration. So that's I take H plus concentration over OH minus concentration equal to 10 raised to minus 7 at neutral. So pH will be negative logarithm of H plus concentration. So pH will be that 10 raised to minus 7. So pH is 7. At pH equal to 7 at neutral and doing at 25 degree centigrade. Okay, so if temperature increases or decreases, then H7 will, value of 7 will increases or decreases. But remember that Kw equal to x square. This will be always at neutral. So this will at neutral at all temperature, because neutral means both have the same concentration. Neutral means OH minus concentration is equal to H3 plus concentration, right? So this is equal x, this is x. So at neutral, at all temperature, at any temperature, we can take this will be equal because this is neutral. So Kw equal to x square. So x equal to, I can write Kw root. So this is valid for all temperature, but condition is for neutral. Okay, so let's take for the acidic. For acidic, H plus concentrations is more than OH minus concentration. Okay, for acidic, H plus concentration is more than OH minus concentration, and Kw is H plus concentrations, OH minus concentration. So for acidic, H plus concentration is more than, for neutral you have taken that H plus concentration is 10 raised to minus 7, and if it is acidic, then H plus concentration is more, then I can say that H plus concentration is more than 10 raised to minus 7, because this is the like center. This value is the center point. So if H plus concentration is becoming more than OH minus concentrations, then H plus concentration will be greater than 10 raised to minus 7. So pH will be, pH will be more than, so pH we can write 7, that is less than 7. Yes, so pH of acids can be, that will be less than 7, so that will be 6, 5, 4, 3, 2, 1. So for acids we are getting pH equal to 6, 5, 4, 3, 2, 1. Similarly for base, OH minus concentration is more than H plus concentrations. Okay, it means OH minus concentration is more than 10 raised to minus 7 value. That means H plus concentration will be less than 10 raised to minus 7 concentration. So pH of base are 10 raised to minus 8, 10 raised to, are 8, 9, 10, 11, 12, 13, 14, 8 for 25 degrees centigrade. If temperature increases, then it may reduce to 12 degrees centigrade of, up to 12. So like, because pH is dependent on temperature. So what is studied that pH, so for neutral, then pH equal to 7, and for base pH equal to, pH is greater than 7, that is 8, 9, 10, 11, 12, like this. And for acids, pH is less than 7, that is 1, 2, 3, 4, 5, 6. So this is a 25 degrees centigrade. So if increase or decrease temperature, then this neutral value may shift to pH equal to 6 if temperature is increases. So if we study at 25 degrees centigrade, this will be the pH. So we will solve one related questions. Yes. So what is Kw of H2 at 370 degrees? 1 into 10 raised to minus 12. Identify which of the following is incorrect. So I says that Kw, they say that 10 raised to minus 12. So we generally used to say K raised to 10 raised to minus 14. This is at 298 Kelvin or 25 degrees centigrade. So if you increase the temperature, like if this is 298 Kelvin, so this is at 373 Kelvin. So if temperature increases, then this value also increases, because 10 raised to minus 12 is more than 10 raised to minus 14. Negative value is there, right? So this value is more than this value. So if you increase the temperature, then this Kw also increases, because this is what, endothermic Kw, this is equilibrium constant, and for and dissociation of water is a endothermic process. So for endothermic process, what is it? If temperature increases, then Kw increases, and temperature decreases, then Kw decreases for endothermic process. So dissociation of water is a endothermic process. So for this, if you increase temperature, then Kw will increases. So 298 Kelvin, generally we used to taking this, and this value is fixed. In the books, generally we found that 10 raised to minus 14, and they generally used to calculate at 25 degrees centigrade. So maximum times 90% they have given this value, because generally they used to take constant at this value, and they are assuming that at 25 degrees centigrade everything is going on. But if you change the temperature like here, then this value maybe changes. So here, that's what they say. Kw Kw of water at 373 Kelvin is this. Identify which of the following is incorrect. So if this value is this, then what we have studied that, so at neutral, what we have studied, neutral, Kw equal to H plus concentrations. So can see that, and at neutral, what we have studied, this H plus concentration equal to H minus concentrations. That means Kw, if I take this is x, then this is equal to x square. So x equal to root over of kW. Yes. So what is given that kW is 10 raised to minus 12. Then H plus concentrations will be, because these are same, so I can take H plus concentrations and OH minus concentration is same, so that I will take this. Okay, kW equal to x square equal to 10 raised to minus 12. So this x equal to, I can write 10 raised to minus 12 to 1 by 2, that 10 raised to minus 6. So the x is h plus or h minus equal to 10 raised to minus 6. So what is this is the pKw for H2O is 12. Yes. So if Kw is 10 raised to minus 12, that Kw is 10 raised to minus 12, then pKw will be negative logarithm of Kw. So that is minus log 10 raised to minus 12, that is comes to be 12. So this option is correct. And pH of water. So pH means we are calculating the H plus concentrations. So here H plus concentration is 10 raised to minus 6. So pH will be negative logarithm of H plus concentration. So negative logarithm of H plus concentration is how much? 10 raised to minus 6 is there. So pH equal to 6. So this is also correct. And H2 is neutral. Yes, H2 is neutral because Kw of water 370 degree centigrade. So if the temperature is increasing, then Kw value also increasing. So that's gone to 10 raised to minus 12. So it is occurring at neutral only. So it is neutral. And H2 is acidic. No, this is at neutral. So incorrect option is option D. So for this, D is correct. Another questions they ask related to that when temperature is raised to at 25 degrees centigrade, H2O H plus concentration is 10 raised to minus 7 and pH equal to 7. Yes. When temperature is raised to 90 degrees centigrade, H plus concentration is become 10 raised to minus 6 and pH equal to 6. So solutions become what? Neutral. Because if they increasing the temperature, then this value also, when 25 degrees centigrade, it is H plus concentration was 10 raised to minus 7. So pH was 7. And where they increases the temperature to 90 degrees centigrade, then if temperature will increases, then Kw also increases, because Kw is endothermic process, and for endothermic processes, if temperature increases, then Kw also increases. So this Kw is increases. So previously Kw was 10 raised to minus 40. So when temperature increases, then Kw become 10 raised to minus 12. So if 10 raised to minus 12, then H plus will be 10 raised to minus 6. So this is become 10 raised to minus 6 and pH equal to 6. So these all things is happening at neutral. Why? Because for neutral only, we can say that H plus concentrations equal to OH minus concentrations. If this is equal, then only we can take that this is X, this is X. So Kw equal to X square. So that X equal to Kw root. And if Kw is 10 raised to minus 12, then root kW is minus square root, that is equal to 10 raised to minus 6. So for neutral, that's why we are taking this as same, and we take this x square and we do the square root, and we are getting 10 raised to minus 6. So this everything is happening at neutral. Okay, so we will solve some we first studies theory. After that we will solve the related examples. So we have studied that pH is for acidic, this is less than 7, and for neutral pH equal to 7, and for basic pH is greater than 7, and it is happening at 25 degrees centigrade. Okay, so we have studied the how to calculate the pH of the strong acids. Like a strong acid, we have already said that strong acid. Suppose if I say that HCl, let's say past we studied the calculate the pH of strong acids. So for this, suppose HCl has H plus concentrations equal to 10 raised to minus 2, then find pH of the solution. So here both water in the solution means both water and H plus concentration from HCl is present, but water means that is neutral. So water also dissociate into H plus plus H minus, but this concentration is 10 raised to minus 7. We have already discussed. And for HCl, this going to give H plus plus Cl minus. So this is completely dissociate, and it is having 10 raised to minus 2 molar, and this is 0 0, and let me do here. So HCl, what it will completely dissociate plus Cl minus. So suppose this is 10 raised to minus 2 molar, T equal to 0, then this is 0 0, and T equal to T equilibrium, this will be 0, and this is 2 molar, 10 raised to minus 2 molar. So H plus is coming both from here and here, but this concentration is 10 raised to minus 7, and this concentration is 10 raised to minus 2. So 10 raised to minus 2 is very large than 10 raised to minus 7. So we will just neglect the H plus concentration from water because this value is very less. The concentration H plus is 10 raised to minus 7. We have studied that. For neutral, H plus concentration from water is 10 raised to minus 7 at 25 degrees centigrade. So this value is very less compared to the concentrations of acid. So whenever you are calculating the pH of strong acid, if concentration is 10 raised to minus 7, then pH equal to negative logarithm of H plus concentration, that will be minus log minus 2, that is equal to 2. So pH equal to 2. So we have already discussed that if concentration of H plus is 10 raised to minus 2, 10 raised to minus 3, 10 raised to minus 4, 10 raised to minus 5, then on the time not include the concentration of H plus from water. And if the concentrations of H plus is 10 raised to minus 7 or 10 raised to minus 6, on that time include the concentrations of H plus from water. Okay, so similarly, if we take the calculate the pH of strong base, then what? Okay, this one we will study later. Let's first cover with acids. First, calculate the pH of weak acids. Suppose HA, weak acid, and the concentration of HA is given like 10 raised to minus 8 molar, and pKa is given 2 into 10 raised to minus 8 molar. Sorry, okay. pK is given of 8 molar. HA weak acid of H is a weak acid of 8 molar concentration is given. Then find pH. So I will solve. So HA is going to dissociate into H plus plus A minus. So T equal to 0. T equal to 0. This is 8 molar is there. So nothing has formed. And when T equal to T equilibrium, so 8 minus 8 alpha. This 8 alpha, this 8 alpha. Yes, because this is 1 molar, this is 1 molar. So from 1 molar, 8 alpha is consuming. Then for 1 molar, 8 alpha will fall. So you know that K equilibrium. So for acid Ka will be what? Concentration of product divided by concentration of reactant. That is 8 alpha into 8 alpha, and 8 minus 8 alpha concentration of reactants. So this will be what? 8 into 8 alpha square. 8 1 minus alpha. So that this will cancel. So this is 8 alpha square 1 minus alpha. And we know that for weak acids, this alpha is very less than 1. So 1 is very greater than alpha. So we can, for compared to 1, alpha is very less. So we can neglect it, take it as 0. So Ka will become 8 alpha square. So alpha square equal to Ka by 8. So alpha equal to Ka by 8 root over. So what I says, Ka is given 2 into 10 raised to minus 8. So put this value, Kh 2 into 10 raised to minus 8, and that is 8. So do it, or we can simply root means 1 by 2. So this cancel, and this will fall. So alpha equal to 10 raised to minus 8, right? This is minus 8, so minus 8 into 1 by 2. Here 2 into 2 into 1 by 2. So this cancel, this cancel. So 4. So alpha equal to how much? 10 raised to minus 4 by 2. So as we have to calculate the pH, then H plus concentrations we need. So that is 8 alpha equal to 8 into 10 raised to minus 4 by 2. So this cancel, that is 4 into 10 raised to minus 4. Okay, so we get that 8 alpha equal to H plus concentration equal to 4 into 10 raised to minus 4. So pH equal to negative logarithm of H plus concentration, that is minus log H plus concentration is 4 into 10 raised to minus 4. So that is how much? 4 minus log 4. So 4. So 4 we can write 2 square. So log 2 square will be what? 2 log 2. So 2 log 2 is 0.3, that is equal to 0.6. So log 4 we can write minus 0.6, that is 3.4. So this is the pH of the weak acids. And next we will study the mixtures of two strong acids. So how will say that let's say if B1 of strong acids has normality N1 mixed with another strong acids of having volume B2 with normality N2, then solution 1 H number of moles will be N1 B1, or we can say solution 1 H concentration of H plus, or you can say H concentrate solutions 1 H number of moles of H plus each N1 B1, and solutions 2, that is another acid, H number of moles of H plus is N2 B2. So if you add this one, so ask the combined pH, then what we will do, just add the concentrations of H plus number of moles of H plus from solution 1 and H plus moles from H2. So combined pH will be N1 B1 plus 2 B2 by total volume. So we will solve the examples related to this. It will clear. So this example. So what he says, 10 ml of, so we know that N equal to mx. So this is normality and this is molarity and this is factor, that is for acid, that is number of H plus, for base number of OH minus. So that N equal to mx, this is the relationship between this. So you can remember as like capital N, so this N will come up in alphabet after that. So this is more, so this value, for getting this value we have to multiply M with X. So this M is molarity, and if we multiply it with the factor X, that is number of H plus or number of OH minus for acid or base cases, then we will get the normality. So what is given here, that B1 is given, that is 10 ml, M1 is given that is 200, 1 by 200. So this one I can write 1 by 2 into 10 raised to 2, that I can write how much, 0.5 into 10 raised to 2. So this I can write 5 into 10 raised to minus 3. So what I says, simply write m1 equal to 10 raised to minus 3. And for solutions 2, that is b1 is given 40 ml, m2 is 1 by 200, that is again 10 raised to minus 3. Just a minute, that is 1 by 200. So 1 5. So this will be how much, 1 by 200. So I can write 2 into 10 raised to 2. So this one I can take above, then this is 10 raised to minus 2, and this will come as 0.5 10 raised to minus 2. So this I can write 5 into 10 raised to minus 3. So this value is 5 into 10 raised to minus 3. So this is 5 into 10 raised to minus 3. So simply now for mixed solutions, what I do, and since normality equal to molarity into x, so here the x is how much, 2 moles, because H2SO4 dissociate into 2H plus SO4 2 minus. So here number of H plus is 2. So we have to do that whenever for so here 2H is coming from here, so we have to multiply it with here 2. So here also 2. Why? Because this H2SO4 give you 2H plus. So we have to take the molarity for 2H plus. So we have to multiply with this. So this will come, that is equal to 10 minus 3 into 10. So this will become 10 raised to minus 2. So this M2 also become 10 raised to minus 2. So now simply do M1 B1 plus M2 B2 B1 plus B2. So this value will be M1 B1, how much, M1 is, so 10 raised to minus 2, and B1 is 10. Hmm, 10 plus M2 is how much, minus 2, and B2 is 40, is divided by 40, that is B1 plus B2, that is 10 plus 40, that is equal to 50. So this value will be how much, it will become 10 raised to minus 1, that is 4 into 10 raised to minus 1, this is 50. So this value will be 10 raised to minus 1, I take common, then 4 plus 1, and this is 5 into 10 raised to 1. So what I'll do, that is 5 into 10 raised to minus 1. So below is 5 into 10. So if you take it above, then this will become 10 raised to minus 1. So 2 minus 1, that is minus 2. So this cancels. So this is become 10 raised to minus 2. Okay, so H plus. So the resulting pH. So we are getting that H plus concentrations. H 10 raised to minus 2, so pH is negative logarithm of H plus concentrations. That will become what? So minus 2, then minus minus 2. So pH equal to 2. So option B is correct. So similar problems. Okay, so another examples regarding this pH mixture. So what happened that for this case M1 is given 1 by 200. So if you do that, then this is become 5 into 10 raised to minus 3, and V1 is given 400 ml, and for M2 that is given 1 by 100, 1 by 100, that is 1 by 10 raised to 2, that is equal to 10 raised to minus 2. So M2 equal to 10 raised to minus 2, and B2 is 400 milliliter, and with B3 200 ml of water is also added. Okay, so what I said, and B3 is also given 200 milliliter of water. So for this, the number of moles of H plus concentration I will get. So since this H2SO4, this will give into 2H plus SO4 2 minus. So 2H plus is coming from here. So what I will do, for M1 I will multiply with 2, and similarly here only one H will come. For HCl, dissociate into H plus Cl minus. So 1H is coming, so here multiplied by 1. So number of moles of H plus concentrations, so total H plus concentrations will be what? All the number of moles of H plus concentrations. So from here, this is this value. So what I do, M1 B1 plus 2 B2, because number of moles equal to molar mass by volume. Sorry, because molarity equal to number of moles by volume. So N equal to M into B. So that I am getting the concentration number of moles of H plus concentration, that is M1 B1 M2 B2, and total volumes, that is B1 plus B2 plus water also added here, B3. Okay, so what happened, M1 B1, so M1 is how much? 10, that is 10 raised to minus 2, 2 by 10, 10 power 1, 10 raised to minus 3, total equal 10 raised to minus 2, and B1 is 400. Yes, similarly for M2 is how much? 10 raised to minus 2, and B2 is 400, and total is how much? 200, 400, and 400. Total equal for 2 for 6 for 8, 1000. So this will become, that is this value is same. So what I will do, 2 into 10 raised to minus 2 into 400 divided by 1000. So this value will be how much? 8 into 10 raised to minus 2, 10 raised to 2. So this cancel. So that will be how much? 8 by 1000. So that if we take above, then 8 into 10 raised to minus 3. This is H plus concentrations. Yes. So H plus concentration, pH will be negative logarithm of H plus concentration. So that is minus log H plus H, 8 into 10 raised to minus 13. So that is So minus 3, that is 3 log minus 8. So pH equal to 3 log 8, I can write 2 to the power 3, that is 3 log 2 is 0.3, sorry 0. Yes, 0.3 into 3, so that is equal to 3 minus, that is 0.9, so that is approximately come to be 2.1. Yes, so this is the correct. So now this is the mixtures of strong acid and strong base. Now suppose mixtures of strong base with strong acids. For this, what? Suppose solution 1, solution of strong acid H N1 V1. Normality is N1 and volume H V1, and solutions of strong base H, normality N2 and V2. And what it says that whether so strong acid H N1 B1 and strong base H N2 B2. And if you are adding this N1 and B1, then what happened? First we will check if N1 B1 is greater than N2 B2. N1 B1 means concentration of H plus, because N equal to N by B. So for this concentration H plus or OH minus, then what are doing? MB. So for this M, for molarity, and normality is simply, normality means M into X. So just X factor will come. So for normality and molarity is same. If for monoatomic or monobasic, M equal to X, M equal to M. So if N1 B1 and B2 is greater than this N1 B1 is for strong acid, then this will be acidic, and for this case H plus concentrations will be what? N1 B1 minus N2 B2 B1 plus B2. And if concentration of N2 concentration of OH minus is more, then what happens? N2 B2 is more than N1 B1. Then what happens? This is become basic because concentration of OH minus is more. So for that, I will calculate OH minus concentration, that will be N2 B2 minus N1 B1 B1 plus B2, and these solutions will be basic. So examples is given. Example, what it says that pH of a solutions obtained by mixing 50 ml of, so 50 ml of 0.N HCl and 50 ml of 0.2 NaOH. So HCl, what it says, the volume is 50 ml, and N1 normality is 0.1, and for NaOH, what it says, suppose V2, there is also again 50 ml, and normality is 0.2. So first we will check which is more. So first we will check the number of moles of H plus. where whether H plus concentration is more or H minus concentration is more. So for number of moles, what are you doing? N1 B1. So this is 50 50, and this is for like we are taking this into for 1000 liter. So this I can write 50 into 10 raised to minus 3, and this is, and it little bit more less, and 1 B1 equal to, what I write, 50 into 10 raised to minus 3. Why I'm taking minus 3? Because I want to take in a liter. That is in 1 liter, that is 5000. So that is 1000 milliliter. This is also milliliter. Into B1 is power into 10 raised to minus 1. So what I do, this I can cancel, milliliter I cancel. So this is 5 into 10 raised to minus 2 into 4 into 10 raised to minus 1. So this value will be how much? 20 10 raised to minus 3. That is equal to 2 into 10 raised to minus 2. And for here, and to B2 we can take for calculating that whether H plus concentration is more or OH minus concentration is more. For this means we are calculating the H plus concentration. Okay, number of moles of H plus. And for here, number of OH minus will be, number of moles of OH minus will be into B2. So B2 is 50 ml by 1000 ml into 2 into 10 raised to minus 1. So this I can cancel, that is 5 into 10 raised to minus 2 minus 2 into 2 into 10 raised to minus 1. That is 10 raised to minus 3. So this is equal to 10 raised to minus 2. So this is 2 into 10 raised to minus 2, and N2B2. N2B2 means OH minus concentration. So OH minus concentration is this, and H plus concentration is this. So which is more? H plus concentration is more, because 2 into 10 raised to minus 2. H plus concentration is into 10 raised to minus 2, that is equal to 0.02. And OH concentrations we get, that is 10 raised to minus 2, that is 0.01. So which is more? This is more. So H plus concentration is more than OH minus concentration. So since this is more, then what will take? This N1 B1 is N2 B2 B1 plus B2. Since H plus concentration is more, then this will be acidic. It will neutralize and remaining will be acid. So N1 B1, N1 is how much? N1 is 4 into 10 raised to minus 1, and B1 is 50 minus N2 is how much? 2 into 10 raised to minus 1, and that is 50, and 50 is 100. So this value will become how much? 20 minus this is how much? 10 by 100. So this will become minus 10 by 100. So this will become this will become minus 10 raised to minus 1. I think wrong here. So this value is more. So that's why I write this is 4 in 10 raised to minus 1 into 50, and this value is this, so this value has to be positive, right? This is 20 minus 10, 100, so this will 10 by 100. Okay, so this is has to come into 10 by 100 means 10 raised to minus 1. So pH will be, so pH is negative logarithm of H plus concentration. H plus concentration we get 10 raised to minus 1. So pH is equal to 1. So option C is correct.